Hello, good morning.
Morning, sir.
Okay. Let's do this part and get started. Okay. All right, so what we're going to cover this week are just basic Java program. How do you write, compile, execute simple programs? We're not getting into object-oriented stuff that much. We'll do a little bit of that on Wednesday, but just basically simple programs. Okay. And as usual, look through the outcomes at the end of the week, convince yourself you have the outcomes. Now we're going to do this on Monday and Wednesday. On Friday, we'll have our first discussion about the project. In order to work in this class, you're going to want to have Java on your personal machine, assuming you do some or all of your coding on personal machines. You can do them on machines in the labs at school, but it's so much easier. Very straightforward. Just Google Java download and it'll take you right to the Oracle download page. And you want to download the SE. Java has two parts to it. One is the Java runtime environment. And you probably already have a Java runtime environment on your computer. That's the thing that executes the codes. There's something called a Java virtual machine. And the Java virtual machine, it's not a real machine, it's a virtual machine. The Java virtual machine is taking your code and turning it completely into machine code and executing it. Why did they do that? Well, those of you that came from C understand that you wrote a C program and then you had to do something called compilation where you compiled it. That converted your C code to machine code. And it usually ended with a .exe. Anything that ends in your .exe on your machine is executable. The problem is if you take your code from C and you compile it and you get a .exe file and then you want to show your friends how cool your program is and you put it on their machine, it may not work. And it may not work because there's a different chipset or there's a different operating system or something like that. And so you can't move the code around from machine to machine. That's called portability. And the people who designed Java wanted it to be portable. So what they did is they put this virtual machine in between you and the physical machine. So you take your Java code, you compile it, you can take it to any machine. And the Java virtual machine will handle all those differences in operating systems and physical chip differences, things like that. So you download and install Java. Then you want to know where, you use the default, right? Whenever you download and install something, I'm sure all of you or most of all of you have done this before. You download and install some software and it always says, hey, where do you want to put it? And put it in the default location. You want to know where this thing is. And the reason is there's two important files that you need to run. One is Java exe. Notice it's an exe, it's an executable. And one is javac.exe, also an executable. Javac is the compiler. Java actually runs Java programs. Now, I don't use Eclipse. I run from the console. So you'll see me typing Javac and Java quite a bit throughout the semester. And if you want to run from console, you have to know where those pieces of code are also. How do you know? Well, go through your file explorer and you can find it. On a Windows machine, the default location is always the top level, which is the C drive, and then program files. And there's Java. And notice I have a JRE and a JDK. The JDK is called the Java Development Kit. That's where you can write programs. So right, I told you those two parts. The JRE runs programs. It will not allow you to create them. So if you only have the JRE and you try to compile, you try to create your own Java code, you can't. So I have the JRE and the JDK. The JDK has something called a bin where they put all their files. And sure enough, there's java.exe and javac.exe. But you have to know where those are. And the reason is when you download Eclipse or whatever tool you want to use, sometimes they can find the Java compiler automatically. Sometimes they can't. And if they can't, then you have to go through whatever your tool says. You know, you can Google the steps for this, whatever your tool says to do to show where the compiler is. I was fortunate. I downloaded Eclipse years ago and it worked. I didn't touch anything, it worked. And so I'm terrified to touch anything. Right? So I haven't downloaded a new version or anything. Also, I'm running from console. And if you run from console, which I recommend initially, then you need to know where these files are. Because when you're running from console, what happens is you type the name of something you want to run, and then the computer, the operating system says, okay, you're asking me to run something, and it will go, there's certain predefined directories that it will go look in. And it goes and looks for these things, and once it finds it, it runs it. But if it can't find it, okay, so initially it won't be able to find your javac file, and you'll have to tell it where it is. It's called set path, so you can Google set path for a Windows machine, and then you can, it's an easy thing to do, and then you can permanently set it. So you've got those two things we're going to deal with, Java and javac. This is from the last class, by the way. If I just type Java, it ran. And since I said Java, but I didn't tell it what file I wanted to actually execute, what Java file I wanted to actually execute, it just said, okay, here's some information about the Java command. And so it's telling me all these options that I have. And the same trick with javac, it actually runs. And since I didn't tell it what file to compile, it just said, okay, here's a bunch of stuff you can do. There's a bunch of options you can do. Oh, let's do this, javac dash version. And what do you know? It tells me the version number. So, okay, so you're going to see me do this a lot, Java and then javac. Those of you that came from MATLAB, as I recall, MATLAB is not a compiled language. You write your MATLAB file, and then what's the extension? Is it .m? I can't remember. I very rarely use MATLAB. And then you can run it. Well, what's happening is the MATLAB software is acting like the Java virtual machine. It's actually taking your code, compiling it in real time, turning it to machine language in real time for you. So you don't have to do the compilation ahead of time. If you came from the C class, then compilation is I think a pretty standard thing for you to do by now. And you've already learned, once your code compiles, you know, that's cause for celebration all by itself. Even if it doesn't execute properly, the fact that you compiled without errors is a good thing. Okay, so those are the first thing you want to do. Download and install Java and make sure you know where the system did it. You want to use the default options here. If you do choose to, you know, I don't like the default, I want to put it over here. If you do, then when you go to Eclipse or some other integrated developer environment like IntelliJ, you may have to point to it because they tend to check in the standard places. Okay, I'm going to run from console, as I said. And so in order to do that, there's a couple commands that I want to let you be aware of. First of all, how do you get console to run? You go down here in a Windows machine command, CMD, and ta-da, there's the command prompt. How do you get out? Exit. I use it all the time, so I have it down here on my toolbar. And the main things you need are, in fact, let me start it from scratch. The main thing you need are to do a change command, a change directory command, and a directory listing command. The change directory command is cd. Now I told it change directory and I didn't tell it what to change to, so it kept me in the same directory. And if I do dir, it'll tell me everything that's here. Oh, there's a lot of stuff there. Okay. I keep my files for the class examples in C drive, CS225, M02. So if I go to the C drive, there's all my top level folders, CS225, and we're in module 2. So those are the files that we'll look at this week. So I have to say CD, C drive, CS225, module 2. And now look down here, it's changed the directory that I'm in. And if I do dir, this is the exact same listing that I get through the Windows. What you're looking at when you're looking at the command drive is how we had to use computers, back in the 80s and early 90s before Windows came out. And there are benefits to it because you're closer to the machine, right? Microsoft isn't getting in the way of me and the machine. And we used to have to know all kinds of commands, and I don't remember any of them anymore because it's been 30 years. We all had these cheat sheets right on the side of our desk for the shortcut commands. All right, let's do our first piece of code. Oops, I'm just going to get rid of this. Basic console commands. Okay, let's go this. Let's run a first piece of code and then I'll talk about, well, let me do the other environments first. I tend to program using Notepad++ instead of Eclipse because the kind of programming that I do, these little class examples, are so simple and straightforward. I don't, Eclipse is overkill. It's far too much of a heavyweight product. So I'm not an Eclipse expert. If you have questions about Eclipse, go to the lab people. They're good at it, but I'm not. So I just use Notepad. All the examples I do in class will be on Notepad++. You don't want to use like Microsoft Word because Microsoft Word puts all kinds of special metadata inside the file, and the Java compiler has no idea what it is. You want something that saves in basic, pure ASCII text. Okay. So that's how you're going to see me operate these things. And again, know where your files are stored. Once you create your own files, keep track of where they are. File organization is important. If you, whenever I see somebody and they have like all of their classes, all of their homeworks, all of their syllabi, everything like in one big file, it just gives me the shivers, man. That's just someone who's asking for trouble. You want to always break things down and think through file organization. The good news with using something like Notepad is you're in control of that. Now with Eclipse, Eclipse will save the files for you under these projects. And the good news is it offloads that work from you. So, once you know what you're doing and you feel comfortable with it, you don't want to be dealing with that hassle. So Eclipse is very good at doing things for you to relieve the burden of work from you. That's the good news. What's the bad news? You don't know what it did. So I'll generally every semester will have someone working on a project and they say they have an image file that they wanted to bring into their program and Eclipse can't find it. And we have to figure out, okay, wait, where does Eclipse think it is in the directory structure? Where do we have to go to find this thing? Or an output file, and then you try to read it back in as input and Eclipse can't find it. Well, Eclipse put it somewhere. So there's benefits to both. Eclipse does take a lot of workload off of you, but it's doing things on your behalf, and there may be some confusion about exactly what's going on later. We'll get into that. Okay. Yeah, let's start here. When you're learning a new programming language, I don't care what language it is, there's basically 5 things that all languages have to do. This is a nice simplifying thing to think through. 5 things all programming languages have to do. You have to be able to somehow declare variables. Then you have to be able to bind values to those variables. That's the assignment statement. You have to be able to select sections of code to execute. You're turning on and off sections of code. That's if then else layout structure, you have to be able to repeat sections of code. Those are generally for loops and while loops and also recursion. And then lastly, you need I/O. The first four are pretty standard among most programming languages. It's the I/O that's always the most difficult, the ugliest, and the most unique from language to language. So all we're going to do here is, by the time we're done with Wednesday, is we're just going to do variable declaration and assignment and some basic I/O. That's all we're going to do. We're going to save if, then, else's and loops till next week. Okay. And the way we do that is we run a hello world file is the first program. Now, hello world, let's start with hello world. We need to build a class. I'm going to use it in Notepad. I've already got it in Notepad++. We need to build a class. So let's see. There you go. Start your classes this way. Public class hello world. Public. What are you telling the machine here? Public. You're telling the machine that this class is publicly visible to external entities, like the Java virtual machine, other classes. Then the next word, class. You're telling the Java compiler, hey, I'm about to define a class now. Get ready. And then hello world, that's the name of it. Open curly bracket, close curly bracket. Curly brackets always designate sections of code. So we're saying open curly bracket, my class definition starts now. And close curly bracket, my class definition ends now. Is this a complete class? It actually is. It will execute. It does nothing, right? No attributes, no methods. What's a class? We said the other day, the class or an object was composed of attributes that describe state and methods that modify the state. So we always have two basic sections here, attributes and methods. The naming convention, I call it hello world with a capital H. Why a capital H? To remind myself, that's a class. It's not an attribute, it's not a variable, it's a class. And then why a capital W? That's the camel hump notation. So every time, if you're going to have descriptive names, they tend to be more than one word. Every time you have a new word, you put a capital letter in there. Now we need to write some code. Okay, so let's make something work. Let's see. We're going to call this thing, we're going to ask the Java virtual machine to run this class. And what the Java virtual machine is going to do, it's going to look for a special method. And when those of you that came from the C class, this won't shock you. It's going to look for a method called main. And so when you say to the Java virtual machine, hey, run my hello world class, the first thing it's going to do is look for main. If you don't have a main, it will say, I can't find main. I cannot run this class. So we have to create a main method. Now, again, I'm saying method, think function. Right? We call them methods in the object-oriented world. Why? Because they're methods by which you can change the attribute values. So I need this to be public main. I'm going to add to this. Okay, now in a function, if you have parentheses and you're defining the function, what do you put inside those parentheses? Let me ask it a different way. Could I leave it blank?
Yes, you can leave it blank unless
Yes, I can leave it blank. Can I put something in there if I choose to?
Yes, sir, you can.
Yes, I can. Right. I can say this is, and that becomes the input. So what do you put inside the parentheses? The input, right? The variable being passed in, right? This is the input. And the input that we're going to put in here is string args. Why? That's the rule. That's the rule. It's basically an array of strings. All right. We also have to, if this method returns a value, we have to tell the Java compiler what kind of value it is. Is it an integer? Is it a character? Is it a string? But the main method never returns anything. It never returns a value. If you create a method that doesn't return a value, and you will create many of these, by the way, if you create a method that does not return a value, you still have to tell the compiler what kind of value came back. Well, if I don't return anything, what is it? And the word that they settled on was void. So it's public, everybody can see it. Void, it doesn't return a value. Main, that's its name, and it can take in an array of strings as input. And one last thing, static. Public static void main string args. It's got a nice rhythm to it, right? Public static void main string args. Why static? Okay, what is, let's see, what's the opposite of dynamic? What's the opposite of static? Dynamic. What does dynamic mean to you?
It means that it can change.
It can change, right? If you're in a dynamic situation, hey, we're in a dynamic situation here, it means it's changing. If you're in a static situation, it means it's not changing. And so what static means in the context of Java, like if you want to declare a constant attribute, you declare it as static, meaning it can't be changed. With methods, if you declare them as static, it means they cannot be changed. And it means not only can that not be changed, if it cannot be changed, it exists all the time. It's a weird thought. It exists all the time. Why is this? Go back to the object-oriented paradigm. Remember the other day I said we have these class definitions like the sheep and the sheepdog, or right, the sheep and the sheepdog. We had class definitions. And remember the sheep, we had one definition, but then we built 3 sheep. So there's a distinction between the class, which is the definition, and the object, which is an instance of the definition of the class, or an actual constructed object. So we could have the sheep class or definition, and then we built 3 sheep objects. And remember, I did say, often we use the term class and object interchangeably. Normally that's okay. Here we need to make a distinction. The class is the design, it is not an object. Then, so we had a sheep design, and then we had 3 sheep objects. Now it turns out you cannot access the attributes and the methods of a class until you build an object of that class. So if I make this not static, I am not allowed to run the main method until I build an object of this class. Think about how you're going to start a program. You want to start a program. Java Virtual Machine says, okay, I'm going to go start the program. I need to run the main method. Once you run the main method in a normal program, and we're not doing it here, once you run the main method in a normal program, now you start to create objects. That's what usually the main method does, is it kicks off a bunch of object creation. Once you create those objects, then you can use those methods. Well, before you've started your program, how many objects have you actually created? Before you start the program? 1. Actually, less than that. Any guesses? Less than 1? You haven't created any objects yet.
0.
Yeah, you have not created any objects. So if you haven't created any objects, and we haven't created an object of the Hello World class, how could we possibly run main? Right? So I haven't created any objects. I have to run main to create objects, but I can't run main until I create an object. See the paradox? So we make it static, meaning this thing exists even before you create an object of that class. This thing exists. That's what it's there for. Public static void main. Now, if you want to do it differently, try it. Won't compile. I'll show you examples. Won't compile. Okay. So that's what Hello World is about. And then all Hello World does is it prints out Hello World. So let me show you what it looks like in Notepad. Public class Hello World, and then public static void main. Notice in purple, these are all the reserved keywords for Java. And Eclipse will do something similar, right? It'll color code things. public void going string args. And then all I do on line 15 is print out hello world. How do I do that? System.out.println. Remember the 5 things that all programming languages have to do? And I told you IO was always the ugliest and most differential between programming languages. Well, in Java, that's how you print the console. System.out.println, println. And yes, you have normal print. Those of you that are familiar with print or printf or fprintf, you know, for formatted output, you know, you have these different capabilities. But right now, just system.out.println. Usually when I'm learning a new programming language, you know, for the output, I'm not even going to worry about that. It's like, okay, that's what they told me to do to print something out. That's what I'm going to do. And then once I need to learn something more complicated, then I will. So that's the whole program. That's Hello World. Hello World is a traditional first program in classes like this. It's a traditional first program when you're learning a new language. My recommendation, if you want to learn a new language, you download the language to your machine and you create a Hello World in that language. And the reason you do a Hello World is basically just to make sure that everything is installed correctly. That's the main purpose of it. Working a research project with the FAA, and students are building simulations, and they said this right out loud on the telecom the other day. We ran the system, we ran a Hello World. And that told everybody on the phone call, at least people who knew anything about computer science, oh, all they did was they made sure that it could talk, right? That's all they did, that's a good, important first step. Once you have a Hello World that works, you can pretty much program anything, right? You know that your Java installation was correct. In a class like this, Hello World is good as just an introductory program to the language because you're getting pieces of the language without too much clutter. You're learning the notation of the language without too much clutter. Okay, some notes here about style and also, you know, I have public class. Why do I have a public class Hello World? Well, all your classes should be public. You never need to make a private class. By the way, the textbook has some examples of private classes. Ignore that. Ignore that. So a couple of things to think through right off the bat. Every class gets its own file. Oh, and by the way, the name of the file has to match the name of the class perfectly, including capitalization. So I have Capital World, right? The class name is Hello World, capital H, capital W. The file name is hello world.java, capital H, capital W. Has to happen. Now you can get, this is one of those things where you can get like an hour's worth of frustration and then it's like, the W wasn't capitalized. So be aware of that. Capitalization matters. Classes should be public. Attributes should be private. Almost all your methods should be public. What about static methods? Meaning you can always have access to them. The only static method you should have in your program is main. Period. I will find throughout the semester, there will be students typically that, oh, I can't get my code to work and I can't run this method. I made it static and now it works. And I always tell them, you have not solved a problem. You have buried a problem and it's going to fester underground and someday it's going to erupt and come back and get you. You have to fix the problems correctly. I point that out because the author early on uses static methods in the examples, and I find that to be a way to set you up, right? It gets you used to thinking that static methods are normal, and they are not. The only static method you should have is main. In terms of commenting, I'm not big on commenting. The top comment block that I have up there, lines 1 through 8, I insist you have that. Commenting in your code, I recommend minimal commenting. I recommend good code. If you have good code, it doesn't mean comments. When you have someone commenting code, the one way you should look at that or could look at that, and the way I look at it is, man, they must have written some really crappy code if they have to explain it in a comment. Now, having said that, sometimes comments really do help. I also use comments as part of my code development. So when I first create a class, I might create nothing but comments. I have to, it's my to-do list. Do this, do this, do this, do this, do this. But other than that, as far as explanatory stuff, there is a religious war going on in the software community about the value of comments. And I'm coming down more and more on the side of comments mean bad code. The other issue that people in the industry have with comments is this. So you write a comment and then you write code. And then later, like 2 years later, somebody has to change the code. They only have 12 hours to do it. They change the code. They're like, oh, I'll change comment later. And they don't. And now the comment is wrong. It does not even explain the code anymore. So again, write good code and you'll find your need for comments goes away, or at least becomes minimized. I usually comment in my code, I'll put all my attributes in, and then I'll put in a line that just says start methods here, just as a nice visual break. Remember, the classes have two major sections, attributes and methods, and I just want that visual break between the two methods. Other than that, I tend not to comment very much. All this code is available to you in zip files on module 2. I have 2 versions of it. One is annotated, one is not. So I said I don't like comments, but here's my annotated version. Holy moly. And what I'm doing is explaining what the code is doing here for educational purposes. How do I get rid of it? Okay. Okay. I've also tried to refactor some of the author's code that I have issues with and given it to you in a form. So as we go through, I give you plenty of sample code. How do we run it? If I do a directory, whoops, there's my .java files. And then if I want to compile, I have to compile before I can run. Java C, that's the compiler. Hello world.java, and I have to put the .java on the end, and it says, ta-da, it says nothing. Oh, wait a minute. Is that good or bad? That's good. I didn't get an error message. And if I do a directory, whoops, I'll get there. And now I have 2 hello world files. One is the .java, my original .java, which is in the Java programming language, and one is .class. It's partially compiled. It's ready for the Java virtual machine to take it, and the Java virtual machine will finish it down to machine code. The class files are in something called bytecode. It's an intermediate form of programs that was developed by the original Java developers. Right now, Oracle owns Java, and they manage Java, but they are not the original developers. So now I've got a class file. Now I can run it. Java, hello world, ta-da, hello world. System works. By the way, you comment things using double lines. If I took everything out, basically this is, because everything's commented out, that's my class, right? That's my class right now. I've got nothing in there because everything's commented out. If I save that, you can use the back keys, by the way, if I save that, it compiles. And then when I run it, it says, oh, wait, I can't find main method not found. Please define the main. These are very helpful comments here, by the way. Please define the main method as public static void main string args. Has to be exactly that. So let's put that back in. What if I make it non-static? It compiles. Will it run? Whoops. No, 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 no. Oh, God. And it says, can't find it. Why can't it find it now? Remember, the static method exists even before I created an object of the class. Because it's not static, I have to create an object of this class before I have the access to the method. And I've created 0 objects before I ran the program. So that's why you have to have static. It's good. It's very helpful that, that it tells you these things. My recommendation with all these files is to do exactly what I'm doing. Change them, see what happens. Keep a pristine copy somewhere. Change them and see what happens. Modify them. I'll get questions in class. Hey, what if I do this? Try it. Try it. Sometimes it takes less time to just code up a couple simple classes than and then run them and see what happens than doing an internet search or something. Can you have multiple main methods in your single class? No. Can you have multiple main methods in your program? Yes, because remember, your program is multiple class files typically. And you can have mains in all of them or more than one of them, and that's okay. How do you know which one's going to run? Well, notice how I told the computer to work. I told it to run specifically hello world. So it's going to go to hello world and find main in there. If I had main in other classes, then it would go to that class and find main. Sometimes you do that as part of program development because you have parts of your program built out and other parts not built out. So you want to run this section over here. You stick a main in there. You'll definitely see that as we build up to GUI stuff, because we build the software prior to the GUI, then add the GUI on top of it. Okay, so that's hello world. Are there any questions about hello world so far? If this looks really foreign to you and odd and strange, don't worry about that yet. But by all means, go through and look at the code, download Java, see if you can run it. See if you can run it either in console or through Eclipse. Any questions?
No, sir.
Okay, all right. So I said hello world is the traditional program to run. I am a traditionalist, so I am not a fan of textbooks like ours that doesn't use hello world. I think ours says something like Java programming is fun, and yeah, that to me is a big strike against the author. You go with the old standards. That's my view. But I'm getting old, so okay. The next piece of code. Let's go back here. The next piece of code, let's go back to that 5 things. Oh, okay, create and declare variables. Did we do that? How many attributes did hello world have? Let me bring it back up for you. How many attributes do we have? 0. How many methods do we have?
1.
1. How many variables do we have inside of methods? 0. Right. So this is a pretty simple program, right? No attributes, 1 method, no variables inside the methods. So now let's talk about how we can create and declare variables and then bind values to them. And that's first circle. I call it first circle because I always forget which file I should run. So this is the first one. First circle. Okay, so same trick, right? I've got a comment block on top. And then how many attributes do I have? Sean, did you already say 0, or was that from the last question? Yes, okay, yeah, 0 still, no attributes still. How many methods do I have? Just 1, just main. And now I actually have variables inside the method. I have 3 variables. X location, Y location, and radius. Now, why wouldn't I make those attributes? You know, if you're making a circle, you really should. And we'll talk about that next on Wednesday. So I made these as variables inside of main. And let's see, I'm going to push that off till Wednesday to talk about the benefits and disadvantages to that. Almost always in a situation like this, it's a disadvantage. Okay, so instead of just saying X location, I say int X location. Now, what's that about? This is called variable declaration. I'm declaring, I'm telling the computer what variables or what attributes, you know, if I had attributes, I'm telling the computer what variables I need to use. What am I really doing? I'm telling it to reserve some memory spaces for me. Hey, I'm going to use something called X location, and you need to have a place to store it. And I need a place called Y location. You need a place to store it. Now, I don't know where that storage is, and I don't care. The computer will take care of that. The operating system, the Java virtual machine will take care of that. Those of you that came from C remember pointers, where you actually can point to specific spaces in memory. Huge security risk. Java doesn't really allow that. We're just going to let the Java virtual machine handle all this stuff for us. So I'm telling you, you need to save it in this memory location. And by the way, when I refer to it, I need you to give it certain interpretation. I'm using X location and Y location as integer values. And so the way I tell the computer that I want these to be integers is with int. And notice it's purple because that's a keyword inside of Java. By the way, I would normally use doubles, but for purposes, demonstration purposes. So what I'm telling the computer is, hey, I have two integers, X location, Y location. Store them as integers, interpret them as integers. When you do an operation, a mathematical operation on them, do mathematical operations as if they were integers because they're integers. And then for radius, I didn't want that to be an integer. So for radius, I did double, and double is a non-integer numeric value. It's not intuitive why it's double. We'll talk about that a little bit later in the semester. It's not a long story. It's just extraneous to what we're doing here. So if you need to have integers, how do you know when you need integers? Oh, people's age, that tends to be integer, right? Have you noticed the temperature is always an integer value on the news? That's a weird thing. It's always 72 degrees and not 72.6. But we know, you know from your chemistry and physics classes, that's not real. So you choose what integer values. Speed of your car, if you have a digital speedometer, I'll bet it's integer based. You go from 45 to 46. You don't go from 45 to 45.0001, 0002, 0003, right? You choose what you think makes integer values make sense. Number of people in this class, integer. There's not a half a person in this class. And then you choose what you want to be non-integer numeric. And those would be the doubles. Once you've told the computer that you're going to use these things, then you can assign values to them. So down lines 17, 18, 19, and again, I'm just slapping in values just for grins. And then I print out. Again, system.out.println, same as before, but instead of just having a single quotation mark in here, a single string, I have a string, a plus sign, the name of a variable, a plus sign, a string again. What am I doing? Well, you can take and mix up strings and non-string data separated by plus signs, and what you're telling the print function to do, or the print ln in this case, what you're telling that function or method to do is to take all of these things, convert them to strings, concatenate them all together, print it out. So if I compile and run this thing, Java C, first circle.java, and then Java. Notice I don't have to put the extension on that. Yay, it prints that stuff out. Okay, so it printed out a single string. Circle center is at 20,15. That's a single string. How did it create that single string? It took what I put in the quotation marks, plus location, X location, Y location, using the plus signs. It converted X location, Y location, which are integer values, converted them to strings, smushed them all together, shipped it out. You can even do computations in here, which is a fairly common thing to do. So I compute the area, radius times math.pi. Oh, wait, what's math.pi? Math.pi, let's see, capital M, math, what does that tell you? Capital M, it's a class, right? That's the naming convention, it's a class. And capital P, capital I, what does that tell you? It's all caps. It's a constant, that's what it tells you. So you need the value of pi. All programming languages these days will give you the value of pi. Some do it as a function call, some do it as a constant reference. And so how do you do it in Java? Math.pi. Guess what the math object is? It is an object, capital M math. Guess what the math object is? It's where you get all your math stuff. You need to do trig functions. You need to do powers. It's all in the math. So what's in there? I don't know. That's what the Oracle help pages are for. If you find, oh, I need to use, cosine or tangent, Google it. It's going to be math.cosine, and it's almost certain, and then you have to check, oh gosh, are they using degrees or radians, right? It's radians. Okay, so these things exist. The people who developed Java gave you lots and lots and lots and lots of pre-built classes. The math object or the math class is one of the first ones you encounter. Okay, I'm going to introduce this next piece of code. I'm not going to run it. I'm just going to introduce it. So here's our first circle. Now notice how bad this is. I'm assigning X location equals 20, Y location equals 15. You guys have programmed enough to know that that's not going to work. You need to have, some kind of user interaction, right? So maybe we can allow the user to actually tell us where the circle is, and the user can actually tell us what the radius is. And now we need to do input. And again, IO is always the ugliest thing in any programming languages. How are we going to do input? Well, in Java, again, they've created a lot of different objects for you. You need to use an object, the Java predefined object that understands how to get input from the console. And the thing that they use is called the scanner. So here's this file, and we'll do this one on Wednesday and go through. Same trick, I've got my comment block up top. I've got no attributes. I've only got one method. We're still not really doing object-oriented stuff. We're going to do that with the next circle object. And I have circle with input is the name of the file. That's the name of the class. And I've got this interesting line up here, import Java util scanner. You'll find that once you start doing anything beyond basic programming, or once particularly your IO things and your GUI things, you're going to need to use statements like this. You're going to need to bring in the pre-built Java objects that are useful to you. Import java.util.scanner. How the heck did you even know there was a scanner? That's what Google is for. That's what the tutorials are for. That's what Oracle help pages are for. So we bring in this scanner, and notice how it's framed, java.util.scanner. Java meaning it's part of the Java program, .util meaning there's an object that collects all of the utility functions, .scanner. This is a utility that scans things. Scanning meaning input. And the scanner will default to the console input. And then skip over the stuff for now. We'll play with this on Wednesday, but you notice I have to say, okay, you've done this before in your other classes, right? Ask the user for some input, and then you take the input, and we'll talk about what these terms are, this new, this input, next double, that kind of thing. We'll talk about what that is on Wednesday. And then you have one more circle example, and then we're off to, I think next week is either if then else or loops, or probably both. Okay. See you guys on Wednesday. Have a good one.
Good day, sir.